So you are going to break down some radicals today, which you've done in geometry and Algebra 1. But the first step is making a factor tree. So like for 72, you could pick any two numbers that multiply to get you 72. I'm going to do 9 and 8. And then break those down into their factors. And when you get down to your prime numbers, your prime factorization is all those prime factors multiplied together. So it could look like 3 times 3 times 2 times 2 times 2, or 3 squared times 2 to the third. So if we're going to simplify our radicals, to have a radical be completely simplified, it can't have any factors inside your radicand that have a perfect square factor. And there can't be any radicals in your denominator. So for example, if you have the square root of 25 times 2, 25 is a perfect square, so you'd need to go ahead and take its square root and then just turn it into 5 times the square root of 2. So let's break down some radicals. Okay, let's start with square root of 75. We're going to simplify each one and give the exact value, so no decimals, no punched in a calculator. Make your factor tree for 75. It breaks down into 5 times 5 times 3. And then if you think about what a square root is asking, it's asking what number is being taken times itself. So you have 5 squared, or 5 being taken times itself, and if you're doing the square root of that, that would just give you 5, just plain old 5, not inside your radical. Square root of 5 squared, or square root of 25 is 5, and then you have your 3 that was not being squared or taken times itself, so it's still trapped inside your radical. If you have two radicals being multiplied, easiest way to do it is to don't break them down or anything first, just rewrite it as those two factors multiplied inside one radical, and then break them down. So 6 is 3 times 2, 21 is 3 times 7. If you look at it, now you do have 3 being multiplied times itself, so square root of any factor times itself is just that original number, so I can bring that 3 to the outside, and then 2 times 7 is trapped inside, 3 times square root of 14. This next one, we have some values being multiplied outside a radical. So 2 and 3 are on the outside. They're kind of in their own little world compared to the insides. Let's go ahead and multiply them and turn them into 6. And then 8 times 28 is inside my radical. If I break each of those down, no reason to multiply 8 times 28 and make it into like 200 or whatever that is. Just leave it 8 times 28 and break those down individually. So if you break those down into their prime factors, it looks like that. And then for every 2 that's being taken times itself, you can take its square root and have a 2 on the outside. So square root of 2 squared gives you 2, square root of another 2 squared gives you 2. And then on the inside, you still have 2 and 7. Don't forget the 6 that was on the outside. So if you multiply 6 times 2 times 2, you get 24, and then square root of 14. Let's talk for a minute about adding and subtracting radicals. So think about when you're adding and subtracting variables. You can add like 2x plus 3x and get 5x, because those are like terms, but you can't combine like 2x plus 3y. Radicals are kind of similar. You could add like 2 square roots of 5 and 1 square root of 5 together and go, oh, that's 3 square roots of 5. But you can't add like a square root of 5 plus 5 by itself, or 5 square root 3. So if you don't have like terms or like radicals, you can't combine them. So on this one, I can do 5 square root 2 minus 6 square root 2, which would give me negative 1 square root 2. But then my 4 square root 3 and my 5 can't be combined with the rest. Let's throw in a little division here. So I am going to break this into square root 50 over square root of 225 and look at them separately. 225, I already made a factor tree for, is 15 times 15. 50, 5 times 10, 5 times 2. So if I rewrite these with their prime factorizations and break down my radicals, 225 is nicely a perfect square, so I just end up with 15, no radical in my denominator. 5 square root 2 on top. I can reduce because 5 over 15 is the same thing as 1 over 3. So square root 2 over 3, or 1 square root 2 over 3. The other thing we're going to need to do is if we have radicals in our denominator, we need to perform this process called rationalizing to get them out of our denominator. Otherwise, they're not considered simplified. So if you have square root of 2/5, easiest way to think about that is break that down into square root of 2 over square root of 5. And then we don't want that square root of 5 in the denominator. If we had an additional factor of 5 inside there, we'd have a perfect square, which we would be able to bring outside. So let's just multiply this by square root of 5 over square root of 5, because that's just a fancy version of 1. That'll give you square root of 2 times 5 on top, 5 times 5 on bottom, which does what we want in our denominator, because you just end up with plain old 5 there. So it's square root 10 over 5. The next one, only our denominator has a radical. So I could multiply this by square root 27 over square root 27, kind of like I did above. But actually, I am going to take a different strategy here. So I'm going to think about what 27 breaks down into. It breaks down into 3 factors of 3. So I could bring one outside first. There's lots of ways I could do this. Or I could just think about the fact that, well, I need these paired up because it's a square root. So I really need one more factor of 3 so that I will have no radical left in my denominator. So if I multiply by square root 3 over square root 3, that's going to give me my one additional factor of 3. So then I'll have a square root of 4 factors of 3. So I can take square root of 9, square root of 9, give me 3 times 3 on the outside there. Nothing left inside my radical except square root 1, which is just 1. So I have 5 square root 3 over 9. So you don't have to do it that way. Let me show you a different way you could do it. You could, like I said at the beginning, multiply by square root 27 over square root 27, which if you do that, you have 5 square root 27 on top, and then your 2 factors of 27 inside your radical just give you 27 in the denominator. You do need to check and break down your square root of 27 on top, though. So that means you can bring a 3 outside, which will give you 5 times 3 is 15. And then you'd have to reduce your 15 over 27 to 5 over 9. All right, this one looks a little crazy. So what it's tempting to do is we've been like looking at our denominator and going, hey, let's multiply by whatever square root's down there. Multiplying by square root 5 over square root 5 is not going to work on this one, but I'm going to show you why. So if you do it, yeah, we don't really care what happens on top. But in the denominator, you're going to have 6 square root 5 minus 5. So you got rid of the radical in one term, but now I have the radical in my first term because I had to distribute. So I'm going to have to take a new approach because just multiplying by square root 5 still leaves me with radicals in the denominator. I'm going to multiply by this thing called the conjugate. So the conjugate of my denominator is just my denominator with the sign flipped between both of my terms. So if it's 6 minus square root 5, I'm going to multiply by 6 plus square root 5 over 6 plus square root 5. Now this may not seem like it'll work, but it will, and I'm going to show you. So it's a little bit messy, distributive property on everything here. So 3 times 6 gives you 18. 3 times square root 5 is 3 square root 5. 6 times square root 2 is 6 square root 2. And square root 2 times square root 5 is square root of 10. So all that on top, and no like terms. The bottom, if I multiply those together, 6 times 6 is 36. 6 square root 5, and then a negative 6 square root 5. And then negative square root 5 times positive square root 5 is negative square root 25, or just negative 5. So if you look at what happened here, since I had opposite signs, my middle terms are going to go to 0. So really, I'm going to be able to simplify a lot of this. Not on top though, no like terms, all this have different radicals. Copy and paste that. The bottom square root of 25 is 5, so I just have 36 minus 5 down there. No more radicals in that denominator, which is what I was going for. So I just have that whole thing over 31.